Hello everyone. So today we are going to do a new problem, and the problem is removing nth node from end of the list. So let's go through the problem statement first. So it's a LeetCode problem. The problem number is 19th, and here it is said that you are given a head of a linked list. So basically you are provided with a linked list, and you will have to remove the nth node from the end of the list, right? Interesting. So here in this example, if you see, so this is your linked list, and here you have to remove n of 2 from the end. So start counting n from the end. So this is n1 and this is n2. So basically I'll have to remove this element 4. So after removing, it will transform into this 1 2 3 5, right? So that's what we are supposed to do. So we'll have to n number would be given, that is the nth node from the end of the list which is supposed to be removed. Okay, so that's it. And here are other example that you can see. So if the head is just 1 and n is 1, right? So if I have an input with just 1, right? So it's something like this. So if I have an input of just 1, then and n is 1, right? When n is 1, then n is 1. So this is my first, right? This is my first. Only one element is present in the linked list. And when n is 1, then I am just removing this element only. This is my first and last, right? So when I remove this element, what will I get? There is nothing left, right? So it will be none that I am returning. So my output is none. Okay. And here in this example 3, if you can see, if there are two numbers 1 and 2, and suppose for example there are two numbers 1 and 1 and 2, and when n is 1, right? So I am just removing the last element. When n is 1, then what I have to do is I'll have to remove this element. So I'll have to cut this link, right? So now my output should be just 1. Okay, 1, and this 1 is now pointing to none, nothing, instead of pointing it to 2. Okay, so that's what we have to do it. And let's look at the approach first, like how we can achieve this. Okay, so since it's a linked list, so traversing or accessing any input at any point of time we can't do like in list. Like in list we can directly point and say that n minus 2 is this is the index and we'll have to traverse till here or something like that. But in linked list we'll have to traverse from the beginning. So this is the head, right? So I'll have to traverse from here to access any element throughout its tail, from head to tail. Okay, so to solve this problem, our basic idea is to use two pointer technique again. So what we will do is, suppose for the example, suppose here, right? So I'll take the first okay, 1 2 3 4 5. Okay, 1 2 3 4 5. 1 2 3 4 and 5. I don't need this. Okay, so here what we will do, we'll use a two pointer technique. So first we'll say that this is our head, right? So this is our head, and first we'll say that our head. So first we'll say that we'll have a low pointer, and also we'll have a high pointer here. Okay, and here if you see the input n is 2, right? So I'll have to remove this element, this 4 element. So how I will do it? So first what I will have to do is to remove this. I need some pointer which can point to its previous one, right? So this 3. Okay, so that when I reach till here, I should be able to say that I have reached till this element. Now my 3 should point to 5. Okay, so what we'll do is we will keep on moving. Initially we'll keep on moving the high till the n time, right? N equal to 2. So when I'll move twice, then it will move to high will move to high will move till if I'll move high twice, then 1, it will go first to 2 and then it will go to 3. So it will point to this position, right? 3. And then after when so high will point here, right? So when high will point here, and now if we move low and high at the same time, right, parallelly, if we keep on moving, then ultimately this low will point to the targeted element. So our target element is what? 4, right? Which is but twice from the behind. Okay, so first what we'll do, we'll move this high till end time, and then next we'll move both L lower and high. I mean till the high reaches the end, the tail. Okay, so here now what we will do is we'll move this low to if we'll move this high till the end, so till it is pointed to the none, right? The last is none. We'll move this high till here, 1 2 3, and this low will move at the same time, 1 2 3. So in that way low will point to 5. Well, so this here, so in my second stage what will happen is this high will be pointing here. So this high will point here, 1 2 3, right? So in 3 iteration it will point to the none, and at the same time this low, right, what it will do is 1 2 3. So it will point to 4. So now low is pointing to the exact location where it needs to be. So it needs to remove 4. So low is pointing to 4. Now as I said earlier, right, so to remove any element I need to know what is its previous, because I am removing 4, right? So I need to know what is the previous I mean what is my previous pointer, right? So my pointer needs to be 3. So what I will do for that is I'll have one more pointer saying prev, right? I'll have one more pointer saying prev, right? So or p, and or prev, right? Let's have p only. So this P will be initially pointing to just behind low. So what is behind low? It is none, right? So it will be pointing to none. Okay. And when we are iterating through it, when low was moving from head, right, 1, then 2, then 3 and 4, at the same time previous P was also moving just behind it. Okay. So P in the first iteration, when low moved from 1 to 2, P moved from none to 1, and when 2 to 3, then it moved from 1 to 2. So in that way, finally our P will be pointing to this one, right? And in this way, now we have the exact thing that we need, right? So this P is pointing here, so we have the exact setup. So only the final thing we have to do is point this 3 to 5, and so when we are pointing this 3 to 5, so we are not pointing this to 4 now. So in that way, our ultimate linked list is achieved, that is removing the nth node from our linked list. So that is our second element from the last could be removed. So I hope you understood the problem and how to approach it. So now let's go ahead with the code. So as we said, like initially I need 3 pointers, that is prev, that is pointing to none, and then low is pointing to the head, right? And I need that high, right? Low and then high is also pointing to head initially. Okay, now the second thing what we have to do is we'll have to move the high pointer n times, right? So how will we do? And n we have received in our input. So while n is greater than 0, we'll run this many times, right? So 2, and so it will run twice. So at that time what we'll do is we'll just update our high to our next element. High is pointing to next. Okay, now now we have moved this high till here n times. That is, it was initially pointing at 1 and then it point twice, 2 and 3, right? So now high is pointing to here. Now we'll have to move low and high at the same time, so that our low points to this 4 and 3 previous points to the just behind element of low. So how will we do it? We'll run the loop till the high is at the end of the linked list, right? So while I is not none, so when it is none, then it should break. What we'll do first is so when it is moving, I need my high to now move to the next element. I need my low to move to the next element, and as well as my prev. Okay, so before moving my low to next element, what I have to do is I'll have to say that this prev now needs to point to low. Okay, so prev is always behind low. So initially it was just none, and when low in the first iteration, prev points to low, that is 1, and low points to 2, right? Low dot next. Okay, so in this way, what will happen is high will point to, at the end of the iteration, high will point to none and low will point to the exact element that is needed to be removed, and pre will point to just behind low. Okay, so that's it. So now I think, now to achieve our final, what we'll do is we'll say that our pre next needs to be lows next, right? So here lows next, what is lows next? It is 5, right? So when I'll point this pre to lows next, then this will be removed, right? So in our final setup, we'll have something like this. So if you'll see here, in our final setup, this will be this will not be there, and then that's what 3 will be pointing to 5. So let's say this is what happened. So I need this element, right? 1 2 3 5. So 1 2 3 5 will be achieved. So that's why we have to, what we have to do is prev should point to the lows next. So prev dot next. So prev next should point to the, so this prev's next should point to the lows next, right? Low dot next. And finally we will return our head. So this head is always pointing to 1, and so our final linked list become 1 2 3 5, not 4, because now 3's next is pointing to 5. Okay, so that's how we achieved it. Let's run this. And type it. Okay, he is none. I think one thing that we are missing here is, let's look at the constraint first. So constraint says that size will always be greater than 1 and 30. So there would always be at least one element in our linked list, right? And n is always less than size and also greater than or equal to 1. So n will never be 0, right? So in our problem statement, it will not say that don't remove at all. So in our problem statement, when it says that n is always greater than or equal to 1, that means at least one element would be asked in the question to remove. So but here one catch is there, that like suppose for example, if you have an n in such a way that see, if n is equal to the size of the linked list, so in that way what will happen, that high will always point to, I mean when I'm running this iteration, it might be the case that high have already reached the end, right? Because our n is equal to 5, 1 2 3 4 5. So in that case, in this example high has reached till 3 because n equal to 2, but when n equal to 1 2 3 4 5, it will reach till none, right, at the end. So when high have already reached none, then it will not even run, right? Or it will not even run, correct? That might be the case. So suppose for example here only, if you see 1 2, right? So let's demonstrate this with an example. Okay, so I will take 2 elements. So I have taken 2 elements. So suppose my n is 2, right? So I have a linked list with 2 and my n is 2. That means I'll have to remove this first element, right? So when my n is 2, so initially my high will be pointing here, right? So my previous is pointing to none. Previous is pointing to none. Head is pointing to 1. Then low is pointing, this is my head, so this is my low, and this is high, right? And I have n equal to 2, right? So in this case, what will happen? High will move twice, right? So it's none. Okay, nothing. Okay. So when n equal to 2, high will move till high will move till here, right? So in my first iteration, high have already moved till here, none. So n equal to 2 means what? This is my first n equal to 1, n equal to 2 is 1. So I have to remove this element. But when n equal to 2, so with this loop that we have defined, n has already moved, high has already moved till none. So that means, with this iteration, high has already moved till none. So that means this will never run, right? So when this will never run, this pre that was initialized as none in the beginning, it will never get updated to some node, right? So it is always be pointing to none. So there is no way that none can point to 2, right? So in our logic, main logic, what was our idea that any pointer that is behind that low will avoid pointing to low, and it will point to the next of low, right? It will point to the next of low, like we have seen here. So any pointer that is behind low will point to the next of low, right? But here we can't do this because it is already none. But what we have to achieve is this by somehow removing this one, right, which is the initial. So to handle such case, what we'll do is like whenever the previous is none, we will just update our head to the next of it, right? So head will move to the next of this. Okay. So in that way, what will happen is this head will now point to 2, and we are returning head, right? So we have finally achieved our linked list, that is head is 2. So that's what our idea was, right? So that's why what we will do is here we'll just check that if prev is none, okay, if it is still none, that means this iteration have not run at all. That means we can say that we just have to return head of next of it. Let's submit this solution. Perfect. So that was the end of our problem today. I hope you liked it. Thank you so much, and I would ask you to follow this channel for more updating content in the future, and as well as learning and preparing for the interviews. Thank you so much.